Lesson 18, ratio word problems in similar triangles. Let's talk about ratio word problems first. Before we talk about ratio word problems, we need to first define what is a ratio. Right, a ratio is a comparison of two numbers that can be written as a fraction. It is a comparison of two numbers that can be written as a fraction. All right, two ratios that are equal is called a proportion. Okay, they're set equal to each other. And proportions are solved by cross multiplying and dividing. Right, so a proportion is two ratios set equal to each other, and it can be solved by cross multiplying and dividing. Solving the proportion is not the hard part. Setting up the ratio is what's going to be the hard part in these types of problems. So in order to help us organize our information, we're going to use a ratio box. All right, a ratio box is going to be set up very similar to this. You're going to have a ratio column, and you're going to have an actual column. And you've got thing 1 being compared, thing 2 being compared, and a total. So you're going to have 3 rows and 2 columns. And that's how you're going to organize the information. All right, we're going to do one example together, and then I'm going to have you do one example by yourself. All right, so the first example says the ratio of Arabians to mixed breeds in the herd was 2 to 17. If there were 380 horses in the herd, how many were Arabians? All right, Arabians is just a type of horse. We're not talking Arabs. Okay, we're talking Arabian horses. And yes, there is a typo. All right, so the first thing that we want to do is set up a ratio box. All right, in our ratio box, we have a ratio column and an actual column. We always have a total, and then let's talk about the things that we're comparing. We're comparing Arabians to mixed breeds. All right, so we've got our box labeled. Now we can start to plug in the information. Now, the ratio of Arabians to mixed breeds was 2 to 17. So there was 2 Arabians to 17 mixed breeds. To find a total, we add. All right, so the total column is going to be 2 plus 17, which is 19. There were 380 horses in the herd, so there were 380 actual horses total. So that goes in our actual total column. How many were Arabians? So we're looking for the number of Arabians, which means we no longer need information about the mixed breeds. Okay, we only use that information to fill in missing information as far as the ratio and actual and total columns go. All right, so now we have 2 to 19 is x to 380, and we solve by cross multiplying. 19 times x is 19x. 380 times 2 is 760. And finally, we divide to find the number of Arabian horses. 760 divided by 19 is 40. All right, so there were 40 Arabian horses. All right, so use your ratio box to organize your information. And then once you have information organized, you want to use it to find missing information and then set up a proportion to solve. All right, the next example is this. It took 600 kilograms of sulfur to make 3,000 kilograms of the new compound. How many kilograms of other material would be required to make 4,000 kilograms of the new compound? I'm just going to help you set up the ratio box first. All right, so in a ratio box, we have 2 columns. We have a ratio and an actual. And then we have 2 things that are being compared in a total. All right, so we're comparing sulfur we're making a new compound. All right, so our new compound is going to be down here. That's our total, our new compound. So we have sulfur, and it's mixed with other materials. All right, so sulfur plus other equals the new compound. Now let's fill in the information. It took 600 kilograms of sulfur to make 3,000 kilograms of the new compound. How many kilograms of other material would make? So we're looking for other to make 4,000 kilograms of the new compound. All right, so this is our ratio box with the information that we have been given. I would like for you to fill in missing information, set up a proportion, and solve. All right, go ahead and take a moment to do that. Pause the video if you need to, and hit play when you're ready to move on. We'll check this in class. All right, the second part of this lesson is similar triangles. All right, similar triangles are a little bit different than congruent triangles. All right, similar triangles have the same shape and the same angles. However, their sides may be different. All right, so similar triangles have the same shape and they have the same angles. They have different side lengths. All right, two terms that we're going to need to know in order to solve similar triangles. First one is corresponding sides. All right, we know what a side is, okay? But corresponding sides are sides opposite equal angles in similar triangles, okay? In the example down below, if you look, this angle, these top angles are the same, okay? They each have one same mark, which means their corresponding sides are their opposite angles. So 5 corresponds with x. They're opposite of equal angles, okay? So they are the sides opposite equal angles. Once you have found corresponding sides, you set up proportions for those corresponding sides in order to find the scale factor. All right, the scale factor is simply the number that relates to the corresponding side, or the ratio of the corresponding sides. Scale factor is very easy to see when we have triangles that are obviously similar. Okay, they have definite corresponding sides. Scale factors are a little harder to tell in triangles that have quite the contrast of sides. All right. Let me give you just a quick example of scale factor over here on this triangle. If I had a triangle that had a side length of 4 and another triangle that had a side length of 8, 4 is to 8 and 1 is to 2. So the scale factor would be 2 because we're doubling from the smaller to the bigger. That is the scale factor. It's the ratio of the corresponding sides. So if this side was 3, this side would have to be 6 because, again, we're doubling the size. If this side was 5, this side would have to be 10 because we're doubling the size. It's the ratio of the corresponding sides. And notice in the example I just gave you that the ratio is the same for every single side. Okay, so scale factor is the same throughout the entire triangle. It's not going to change from side to side. All right, we're going to look at this example down below. We're going to find the scale factor, and then we're going to solve for x and y. All right, we're going to solve for x and y first, and then we're going to find the scale factor. No, we're going to find the scale factor first, then we're going to solve for the missing side. All right, in order to find the scale factor, we need to do it based on corresponding sides that we know. All right, so we know the side that is opposite from the 2 tick mark angle. We know that this is 3 and this is 4. All right, so the scale factor when going from the bigger triangle to the smaller factor, we have 4 to 3, which means the scale factor is going to be 3/4. Okay, we divided by 4. That's how we got our scale factor. So to go from one triangle to the other, we're going to multiply each side by 3/4. If I do 4 times 3/4, it's equal to 3, which is what its corresponding side is. So in order to find x, I'm doing 5 times the scale factor. Well, the scale factor is 3/4. So we do 5 times 3/4, which will give us x, which means that x is equal to 15/4. And you can keep these as improper fractions. All right, so x is equal to 15/4. In order to solve for side y, we're doing 7 times the scale factor. 7 times 3/4 gives us y. 7 times 3 is 21 over 4, and that gives us the missing side y. All right, so that's scale factor in order to solve for missing side. We're going to do it a different way in a few lessons, but we need to know what scale factor is first. All right, let's look at the second example. We're solving for a and b. We're using scale factor. So we're going to find the scale factor together, and then you're going to solve for a and b. All right, so let's look at the scale factor first. We want to find corresponding sides that we know. We know sides across from the right-hand angle. We know 9 and 4. So 4 is to 9, as 5 is to a, and 6 is to b. So the scale factor is going to be 9/4. Okay, we can use that information. If we multiply this triangle on the left times the scale factor, it'll give us the triangle on the right. So use that information, and you want to solve for sides A and sides B. Go ahead and give this one a shot on your own, and we will check it when we come back into class.